Assalamu alaikum, my dear viewers. Today we are going to solve the numerical on the beams and the condition which we have taken, that is the simply supported beam, and we are going to handle in this numerical a beam which has both point load as well as the UDL. So let's see how we can solve that. So a simply supported beam of span 10 meter, 10 meter. So a beam is there which is simply supported. So let's draw the loading diagram first. So first of all we need to draw the beam. So this beam is simply supported beam. So let's draw the two supports beneath the beam. So this beam is having two supports. So let's call this A and this point is B. So it is the span of the beam is 10 meters. So let's give the span. So that is the length of the beam, which is 10 meters. It carries a UDL load of 3 kilonewton per meter over the whole length. So UDL is separate over the whole length of the beam. So this is the graphical representation of the UDL, which is separate over whole length, and the magnitude of this is 3 kilonewton per meter. Okay. 2 point loads 5 kilonewton and 8 kilonewton are acting at points at a distance of 5 meter and 7 meter from the left end support. So there are 2 point loads whose magnitude is 5 kilonewton and 8 kilonewton. They are acting at 5 meters, that means half of it, and 7 meters from the left end support. So from here, so distance from this point to this point is 5 meters, and the magnitude of this load is 5 kilonewton, and it has one more load which is at the 7 meters from the left hand support. So it means from this point to this point the distance is 7 meters, and here the load, its magnitude is 8 kilonewton. And what we have to do, we have to draw the SF and BM diagram as we did in the previous cases. So this is how the loading diagram has to be drawn first from the numerical, and this is A and this is B. So let's call this point C and let's call this point D. So this is the notation which we have given to the various points, and as I said in the previous case that these two loads which is at A and B, these are the reactional loads. So I will call it RA. RA means reaction at A, and this point I will call RB. So these two are unknown. So let's first point out what is the magnitude of RA and RB, because no, the clockwise movements are equal to anti-clockwise movements. So let's see, we will try to find out the movements about point A, and we'll see which is the clockwise and which is the anti-clockwise. So this 5 kilonewton, if this will make the clockwise movement, this will make the clockwise movement, and this UDL will also make the clockwise movement, and this is what is anti-clockwise movement. So there are 4 forces, 2 point loads, 1 reaction, and the UDL are making the movements about this point A. So this is RB, and it's the distance from the point of line of action of the force, that is 10 meters. So that is 10 is equal, I will take the 5 kilonewton, its distance up to point A, that's 5 meters, plus 8 kilonewton, and its distance up to A, that is 7, plus now this UDL. So UDL, we need to convert this UDL into the load. That is, the load on this beam is 3 kilonewton, the magnitude of that load, and it is separate over the length of 10 meters. So it is separate at the length of 10 meters. So we have converted this into the load and its distance. because we are assuming this UDL is acting at the center, so that means its distance will be 10 by 2 from the center up to the left end, that is 10 by 2. So let's try to find out the value of RB. So what is the value of RB? It's 23.1 kilonewton. So let's write that RB is equal to 23.1 kilonewton, the magnitude of this reaction. So now we know the RB, now we need to find out the RA. How we can do that? So we have two upward forces, so RA and RB. So we will say RA plus RB, because both are upward forces, are equal to the downward forces. So there are three downward forces, 5 kilonewton, 8 kilonewton and the UDL. So that is equal to 5 plus 8 plus the UDL. So UDL is 3 into 10. So we have to convert this into the load. So let's calculate that. RA is equal to 19.9 kilonewton. Now we know the magnitude of this. It is 19.9 kilonewton. Now let's calculate the shear force. Calculations for shear force diagram. So all the upward forces should be taken as positive and all the downward forces should be taken as negative. So upward forces taken as positive and downward as negative. So this is the sign convention which we are choosing. So let's do the calculations. So SF at A. So what is at A? So there is 19.9. So it is taken as positive because it is upward. So 19.9 kilonewton at A. Then, as I have taught you in the previous example, that we have to take the sequence, that is, we will say SF to the left of D. What is to the left of D? There is the UDL to the left of D. So that means plus 19.9 minus, because it is downward, so it is to the, that is 3 kilonewton into, it is separate over the 5 meters. So 5 meters plus 4.9 kilonewton. Then we'll say SF at D. What is at D? So this is again acting downwards, plus 4.9 minus 5 kilonewton. So the answer is minus 0.1 kilonewton. Then again the same sequence, SF to the left of C. What is to the left of C? These all forces which we have calculated, and the UDL from D to C, in between D to C, that means minus 0.1, which was up to D, and minus again because it's acting downwards, so that means 3 into this distance from this point to this point. So this distance is 2 meters, so into 2, so that means it is 6, so minus 6.1 kilonewton. So same way, now it was to the left of C, now at C. So SF at C, to the left was already minus 6.1 minus, because it's again acting downwards, so that is 8. So 8, that is 14 minus 14.1 kilonewton. So now again SF to the left of B, SF to the left of B. What is to the left of B? That is minus 14.1, and again minus, because again this is acting downwards, So it is on the length of 3 meters from this point to this point. The length is 3 meters. So that means 3 into 3. So that is 23.1 kilonewton. And then the last thing, SF at B. What is SF at B? As I said you in the previous case also, that SF to the other end of the beam in the simply supported beam should be always 0. So it is minus 23.1, and this is acting upwards. All the upward forces are taken as positive. So this is plus 23.1 kilonewton. So what is the answer? The answer, this will get cancelled. The answer is 0. Now we will do the calculations for BM diagram. So calculations for BM diagram. So let's do the calculations for the BM diagram. As I said in the previous case, that BM, that's bending moment at the two ends of the simply supported beam, is 0. That means BM at A is 0, and similarly BM at B is also 0. The BM at D. So which force is going to bend point D? So it will be this force and this force. So the upward forces, as you know, has been taken as positive. So we'll take this as positive. So how much force is this? 19.9, and its distance up to this point D, that's 5, minus then this UDL. So UDL we need to convert first in force. That means 3 into this is the magnitude of the force, and it is separate over 5 meters. So we have converted this into force. Then we have to take the distance. That means we have to assume this is acting at the center of this 5 meters. So distance will be then 5 by 2. So let me calculate. So the BM at point D is 62 kilonewton dash meter. So now last point to find out is, so BM at C. This force is going to bend this point C. So that means the magnitude of this force is 23.1 into its distance up to that point, that is 3 meters, and minus this UDL, that is 3, and it is separate. This UDL is separate over 3 meters. That means 3 into 3 is it has converted in force. Now we have to assume that it's acting at the center of the 3, that is 3 by 2. So moment at C is 55.8 kilonewton dash meter. If this is a baseline, and we have to draw the SF diagram. So SF at A, so let's call this point as A. So SF at A is how much? 19.9. So then we need to go to the SF. So this is my point A. So SF at D, to the left of D. To the left of D is, again, it is positive 4 point. So this needs, because this was the UDL, it needs to be shown by means of an inclined line in SF diagram. So I have drawn the inclined line. So the magnitude here is 4.9 kilonewton. So kilonewton. Then SF at D it goes in minus. So 0.1. So this is the point load. It was the point load, 5 kilonewton point load. So we have to show this with the vertical line. So this is minus 0.1 kilonewton. Then SF to the left of C. So this was the D point. So this was D point. So to the left of C is minus 6. Again C, this was the UDL in between. So we have to show this with an inclined line. So this is to the left of C, it was minus 6.1 kilonewton. Then at C, what is at C? at C is again going into the minus 14.1 kilonewton, but here it is vertical load, so vertical load needs to be shown with a vertical line. So here it is minus 14.1 kilonewton. Then SF to the, this was C point, so this was the C point, SF to the left of B. To the left of B, my dear students, you can see further it is in minus, that is 23.1. So again, between C and B, there was the UDL, so we need to show this with an inclined line. So this is minus 23.1 kilonewton. Then SF at B, so at B it's a vertical load, so it becomes the 0, so we have to show with this vertical line. So this is my B point. Hashing needs to be done. So this is minus and this is plus. So this was the SF diagram. So now let's draw the BM diagram. So I will take the space here to draw the BM diagram. So I will draw a baseline. So this is the baseline. So let's take, this was the A point and this is B point. So BM, so let's say this is B and this is C point. So let's draw. So BM at B is 0. So it is 0 here, it is 0 here. At D, so this is the D point. So at D, it is plus 65. So it is somewhere here, 62 kilonewton dash meter. Okay, remember one thing. In case of a BM diagram and this is a UDL between these two points, A and D. So this is the UDL is shown with a parabolic curve. So we have to connect these 2 points with a parabola, and BM at C. So this is the C point, which is 55.8. So it is less than that. So somewhere here, 55.8. So we need to connect these 2 points with a parabola. Then it is 0 here, so we need to connect this with a parabola. So this is the positive diagram, BM diagram, and this. So you can see very clearly that SF has changed the sign at point D, where the SF changed its sign from positive to negative or negative to positive. That is the point where the maximum bending occurs. So this is the BM max. So this was the point, and it has been proved that the maximum bending, so point D in this beam is vulnerable, where the beam can show the failure first. So that was the crux of this question. I hope you enjoyed this question. If you really enjoyed this question, please do subscribe my channel and also press the bell icon. So thank you very much for watching me.